Oh. Sweet.
Who's in here is a Flames fan? Go Flames! Okay. All right, you guys will be excited for this one. Um, Now we have Ryan Kazmerik. He's a director of the data science department at Stellar Algo, where he leads a team of talented data scientists in using data to solve complex business problems in world of sports and entertainment. And in addition to his work at Stellar Algo, Ryan also shares his expertise by teaching a course in game design using Python at Mount Royal University. And furthermore, he enjoys helping students learn the skills they need to succeed in the tech industry. So I hope you guys enjoy this presentation.
I know what you're thinking, who's building video games in Python, but I saw a few people go, what? So, yeah, so really nice to be here today. Thanks for having me. Thanks for that great intro. So we'll just dive right in today. We're going to do about 20 minutes of talk, and then I'll open it up for Q&A at the end. I guess I shouldn't wander too much with all these microphones. Yeah, so I work for a company called Stellar Algo, and I'm the director of data science there. And about 2 years ago, we started building our data science practice. So that's what I'm going to talk about today. And oh, I see a friend in the audience there. So yeah, we're gonna chat about building out the data science practice, and but I'll tell you a little bit about the company first. So, yeah, we're a Calgary tech company that started in about 2016, and now we're almost 100 people inside Calgary and Vancouver and Toronto and kind of all over the U.S. And the really fun part about Stellar Algo is that we work in the sports and entertainment industry. So we're really obsessed with sports organizations and their fans and helping them understand how to connect with those fans better, how to engage them better. And so I'll get into a little bit more detail on that. But really, we provide fan engagement through three core chunks in our engineering core. And so the first one is data management. Well, you know, these teams have a ton of data, really cool data sets. So we've got all their ticketing data, we've got merchandise from Spotify, people are buying stuff on the NBA store, on the NHL store. We've got merchandise, you know, sales within the stadiums themselves, food and beverage, you know, beers and hot dogs inside the Saddle Dome, all that kind of stuff. So there's all these crazy sources of data. But really, at the end of the day, when a team looks at a fan, they really want to see, you know, a unified version of that fan. They don't want to see, you know, oh, I can see he likes to drink beer, and I can see he bought a hat last year, and he goes to a couple games. They want to see, hey, this is Ryan. This is the entire, you know, all the data, the single kind of unit of fan data on that fan. So that's the heavy lifting in data management. And that's our data engineering department, and they're fantastic. Then really, once we have all that data and we have all those fans, the very first thing that the teams ask us to do is, okay, well, now we want to start, you know, being strategic and launching campaigns against certain parts of these fans. So segmenting, we call it advanced segmentation. So, okay, give me all the fans that went to 20 games last year. You know, they spent over $100 on a ticket. I mean, who can spend less than $100 on a ticket these days? But you know, and then you know, maybe they're a fan of the hockey team, but they also go see the basketball team in town. Kind of want to know that. Oh, we want to see people that only live 10 kilometers from the stadium, that kind of thing. So, and then we have a campaign that we would like to launch against that segment. So that's what our platform does. We have a SaaS app product. And then really that's kind of what the web app does. So we can facilitate the advanced segmentation through there. But what we really want to talk about today is the ML driven scoring, and that's kind of what I do and what my department does. So we'll talk about that a little bit today and building out that practice and what that sort of looks like. Yeah, and then the fun part is that we get to work with all these great teams. So there's probably some logos up there that you recognize, and there's 100 more of them. So yeah, we work all over the NHL, the NBA, NFL, the MLS, pretty much every major sports organization within North America we've kind of got our claws into. So yeah, some really fun clients and some really fun use cases. So this is where we started, and I think in the organizations that I've worked in, this doing data science, this becomes sort of a common nightmare. So it really wasn't a data science team at this point; it was our software engineering team. And the first model that they decided to build, or the first problem we decided to go after for teams that we thought we could solve, was something called retention. And really this is just a fancy way to say, can we make a prediction on who's going to come back next year? Can we look at, their behavior through the season? Can we build a model based on, all the historical data that we have? And can we score each fan and say, what is the probability that they will come back next year? And furthermore, we want to get a little bit more granular. We want to know, for our season ticket holders, let's give them a score for coming back and renewing their package. Maybe they're a half season ticket holder. Maybe they buy a mini pack, like the 10 game packs, or maybe they just buy individual tickets. We want to be able to predict what's the probability that fan would come back next year. So that was the first model, and it was, I won't say it was easy to build, but we have a lot of ticketing data, and so we can see who's buying tickets to the games, but also who's actually attending those games. And so you can kind of get a sense for who's really engaging with the team and who isn't, who's going to the games and who's not. So it's a really small set of features. It's all based on ticketing data, but it was working pretty well, and teams were, they were finding it pretty useful. And so then our sales team got their hooks into it, and you can see this kind of thread. This is the reality if you work in a product company, what sales and the engineering team end up going back and forth on. So, sales sees something cool. Holy smokes, we can sell this. Really cool model. Okay, we sold this to a team. When are we putting it into the platform? Okay, we just sold it to 20 teams. And we're like, what? Like, we don't even have this in the platform yet. Okay, we sold it to 50 teams. They're asking for new models, and right? So like, this becomes, it's a good problem to have, for sure. But, the software engineering team down here now is going, oh my gosh, we're scrambling to figure out how to make this work. And really, what they did to scramble was we really had one Jupyter notebook that would run this model for one team. Well, that one team might have 5 products. So now we've got the full season guys, the half season guys, the quarter season. Okay, so that's 5 notebooks now that you have to run for that team. And now sales went and sold it to 100 people. So now you got 5 times 100 teams. So now you got 500 Jupyter notebooks that you got to run every day. And they all take these ones took about, I'll say like 10 minutes to run. And so literally there was somebody on the software engineering team where their full-time job for like 2.5 days a week was to run these notebooks, right? So like, how fun is that job? You're just, especially during COVID, right? Like you're sitting at home and you're just like, start, and you got to make sure it runs. You got to make sure every cell runs and it didn't break down somewhere, right? So this is a huge problem. So that's when we decided, when Stellar decided we needed to, start shaping up a data science practice. And so I'll walk you through kind of what we decided to do with that. So we had a few things you do when you kind of launch a new, practice within a company. So, we had to find the right people. Who are the right people to put, in this department? Do we have them in-house? Do we have to go hire them? Then we need to self-galvanize. What tasks and what workloads are we going to try and tackle with this group? We needed to kind of establish and figure out where this fit within the company and within the product itself. Given that we were really data engineering and software dev heavy at the beginning, it's like, okay, data science coming in, where does that fit? And then we needed to figure out how to communicate our value to the company, the other groups within the company, but also to our customers. Why would anybody care about these models? Why would they care about this stuff? And then we also kind of wanted to kickstart a growth mindset. That's kind of one of our company values. And really understand, like, when would we know if our efforts were working? We want to keep growing, we want to keep changing, but when would we know if we're actually doing something right and keep moving in that direction? So, yeah, I mean, if you're here in the room today and you and you work in a practice, then hopefully some of this is valuable. And if you're interested in a career in data science, hopefully this is valuable too. And just to kind of see the composition of the team. And I think one of the key things that we figured out right off the bat was that we didn't want our data science team to be composed of 5 data scientists. And there's a few reasons for that, but what we've learned is like, it's almost like sometimes a little bit too many cooks in the kitchen, right? You've got, like, all these data scientists in the room, and this hurts me a little bit because I am a data scientist, but you maybe don't need 5 data scientists, because that's like having 5 chefs in a kitchen and having nobody serving the food and nobody giving you any ingredients, right? So we actually thought that the DNA of our team should be a little bit more cross-functional, a little bit more broad. And so we kind of invented these roles out of thin air. Not that they don't exist in industry, but they didn't exist at our company at the time. But when we started building it, we thought, okay, we want a data scientist, but we want a really strong presence in ML ops, and we want a really strong presence in data engineering as well. And we have those functions within the company, but we got a little bit greedy and said, no, we want to build the practice with those roles right in-house because we think they're that important. So the key here was building this cross-functional team. And that was because once we figured out that our model was working well, just like we did with those 500 Jupyter notebooks, way at the top is when we figured out that model actually works well and we think we could sell this to people. We knew that right away then people would ask for that to be deployed. And that's where ML Ops comes in. And I underline properly deployed because there are 10 ways to deploy a machine learning model and there are 9 ways to do it wrong. And so that is where somebody with a real understanding of the ops world can be extremely helpful. An ML data engineer, we also wanted to make sure that we were getting super high quality data into the models, because anybody that's doing modeling or data science in the room knows that you spend 95% of your time cleaning and scrubbing and finding good data sets, and you spend 5% of your time, you spend 3% of your time writing the 3 lines of code to run the model, and then you spend the other, 2% trying to figure out what the hell it did. So that's why we wanted these roles. And the other really core thing was, once we figured out that yes, we need a cross-functional team, it was like, okay, now how does that team work together? And the key to success here was really, by design, creating workloads that were highly collaborative. So, avoiding as much as we possibly could about working in isolation. And that, you can't always avoid that. I mean, there's some tasks you're just going to have to do by yourself. But really, as we started thinking about building out the pipelines and building out the infrastructure, it was like everybody has to learn everything. Now, one person on the team has to be the expert. So there's, the ML ops engineer is going to know more about ML ops than the other two. But everybody needs to know everything. So, okay, we're going to learn Terraform to program all of our infrastructure through code. Everyone's learning Terraform. Okay, we're going to write a new model. Everybody's involved in that process. Okay, we're going to write a new ingestion pattern. Everybody's involved in that process. And that really keeps us away from doing things in isolation. And the overlap here, these tasks that I've listed, are just a few examples of activities that are really we can do them well because you need expertise in a couple of different areas. So, like, for example, like, let's take tracking model drift, for example. You need somebody, you need to understand, how is that model being deployed? How is it being updated? What data is being fed into it from an ML ops perspective? But then the data scientist also needs to know, well, what did we change about the model? Did we add a new feature? Why is it drifting? Is the data just getting old? So it becomes a real collaborative process. Then we had to kind of figure out, all the different facets of things that we needed to work on. So the key to success here, that I've always thought about data science and models in general is, even if you're not a product company, you should try and think about your models like a product, because it will set you up for success when people start using them. So even if it's just you're only building models internally for your company, and that's, they won't go outside to external, think about it as a product, because once you do that, you start to think about, okay, we actually need to make internal improvements. Like we've written that code wrong because we were rushing. We have a bunch of tech debt. We're pulling that data from the wrong spot. So we want to spend time on internal improvements. But once you launch a model into production, now you have a responsibility to keep that thing, running, because people are starting to use it. So you might be supporting models that are currently in use, or, trying to improve the accuracy or improve performance. And then really no department is really, data science department is really getting left in the dust if they're not doing R&D these days, right? Like there's just so much stuff coming out. And the problem is your sales team is asking you for that stuff all the time. They're like, oh, ChatGPT, that should be pretty easy. Can we whip up an in-house version of that? Yeah, no problem, guys. So there's these three facets, right? You got to be looking at new stuff. You got to be improving, internally, and you need to be supporting what's in production. So I've just put a little cap of our Kanban in here, and we essentially, put all that work in the same spot, because we consider that we own the product of data science, and so we have to own that from kind of end to end, right? Another really key thing is, how do you communicate this stuff with other departments? And so you have to really consider the different resolution, like layers of resolution, because data science is, it can be a little complicated, and that's okay. So what you just need to consider is, who am I communicating this to? What's the right, facet to do that with? So when we're talking to engineering, we can send them links to our GitHub and a notebook, and just tell them to kind of read it. And we do a lot of not inline documentation, but markdown documentation as we're writing stuff. If we're talking to sales and account management, and I've been on a few business trips with sales and account management, so that is accurate with the 2 jugs of beer about as big as they are. Yeah, we have a Slack channel where we just keep them in the loop, right? And I put the ChatGPT logo in there because I have been guilty of writing a couple of posts with the help of some AI, but I figure if anybody's going to do that, it's got to be the data science department, right? And then if we're pushing stuff out to clients, that needs to be a bit more polished. So that's kind of when we hit the PDFs. And the last thing I'll touch on here is just the way we structure our weeks and carving out time for certain things that are really, really important. So when we do group training, and we do this every week, we have a slot from 9 to 10 where we do training together. And I think that's maybe the most important part of it, is to do it together. Because especially as a leader, it's kind of a cop-out to say, okay, you guys go do this training course, you find the time, to do this certification. Then I'm also going to load you up with, 50 hours of work in a 40-hour week, and then you're also supposed to do this training, right? So for all the leaders in the room, or if you're running a small team, the best decision that we ever made was, I do the training with my team every week. And we just spend time together learning something new. Excuse me. And then the other big thing that we don't do it every week. We do it every second week, but we block out the entire day on Friday, and it's just like locked out in the calendar. And if we don't do this, we'll never learn anything new, because we'll always be, working on an operational thing. And I think this quote at the bottom kind of does a good job of summing it up. And what I take away from this quote is, it's fine to say that You know, you have a culture of failure and you got to fail 10 times in order to succeed that one time. And that's great. But if you don't create safe space to fail, you know, when the project is 6 weeks overdue and the client's screaming at you and sales is screaming at you and account management is screaming at you, you're not going to go and try and fail. That's when you need to succeed. But you do need to carve out time to fail. And so that's why, you know, these sections are really important, because this is a really safe space for the team to just go and try crazy stuff and not have it, you know, really impact product work. I mean, if you try and claw this back, it's really hard to do. So you really need to just, you know, make a statement and put it in there right off the bat. So those are kind of, yeah, some of the key things that we learned about building the practice, and yeah, hopefully that was helpful. I'll open it up for Q&A now. Any questions?
You highlighted.
Oh, sorry, in the back, and then we'll go to the Blue Jays over here.
He's going first.
No, you go.
Okay. So that group training, was that weekly, like the shorter one? That was like for 1 hour.
Yeah, weekly 1 hour, and then every second week we do the Friday.
So who leads the weekly kind of that weekly training? Like, cause someone's got a topic, someone's got to like put some material together.
Yeah.
Who does that?
Yeah, we do right now. We have an online training platform called a Cloud Guru, and so we pick a certification that we want to go after as a group, and we just work on that. So that's yeah. I'm not writing training material every week, and that's really hard to do. So that's a really good point. You need to find a good like online, and there's tons of them out there now, and they're getting better at staying up to date. We tried one. I was a big fan of Pluralsight before, but they weren't keeping their content up to date. So we switched over to Cloud Guru. And yeah, we just pick a course and chew through that together. And I think the certs are a good way to also provide some more structure around that, right? Everybody's probably got their fingers into a cloud platform of some sort. So go after the basic cert, you know, crush it as a team, then do the next one, you know, just kind of work your way up. Good question.
You highlighted a lot of the development roles on your team. Do you have anyone on the administrative staff to help manage the board and manage how the team planning goes and all that?
Yeah, we have an implementations manager that works outside of our team, and he runs our sprint planning for all of our engineering teams. And so that's a really good point. It's super helpful to have somebody outside your team run your sprint planning if you can, because yeah, you tend to get a little bit kind of, you know, if I did my sprint planning, like 90% of the tasks would be internal improvement, because I always want to make the core of the team better. Whereas our implementations manager, you know, he pushes us to make sure we're still delivering for teams, we're, you know, delivering on the work that people are paying for. So yeah, we have an outside manager.
Is that just for sprint planning, or do you use them for like backlog grooming and stand-ups?
We do that together. It's the same meeting. Sprint plan, backlog groom, same meeting, 1 hour a week. And we just, yeah, we fill up the sprint and throw things in the backlog and they get moved in. So sorry, I'll go here first and then in the back.
Follow up to that one is for the person that's helping with the sprint planning, how much knowledge do they have to have in not necessarily the technical side, but familiarity with the space that you're within?
So they have a lot on what it takes to deliver the product, but not about the data science components. So for example, he'll spin up a card that says, hey, we just signed the Detroit Red Wings. They want the retention model. They want product propensity. They want event propensity model. You guys need to train the model and you need to put it into production. Those are kind of what the cards look like. We take it from there. But he has a really good understanding of like when a new team signs on, what are those 50 check boxes that we need to check? And that's in all over engineering.
So he's the 30,000 foot and you're the
Totally.
500 foot.
Yeah, and he totally keeps us in line. Yeah, it's a really good function. Yeah, back there.
Can you throw more light on the ERP that Stellar Algo uses?
Oh, yeah. Like we don't really have an ERP. We're a SaaS product. We're a complete AWS shop. So we have lots of integrations with other platforms from whatever the client has, right? Because like I think the NHL is pretty deep in Azure, and the NBA is all over AWS, and the NFL is all on GCP, or MLB maybe is on GCP. So we kind of have to play in all those different cloud platforms, but yeah, internally we're pretty heavy on AWS. Oh my gosh. Let's go here first. Yeah.
Okay, just thanks for the presentation. It's very insightful. I'm just thinking about the slide where you say like the responsibility of the data science team first you migrate into new system and then you maintain the in production models and then you do R&D. Like it sounds like a lot of responsibilities, right? And then I'm just thinking about when you scale up your team, like you build a larger team, and everyone is going to share those responsibilities. And as your models in production grows larger more and more, and it kind of like I'm not sure if when there will be a time where it's like, okay, yeah, we're gonna split some people doing like ML ops specifically and some people doing data science R&D specifically, because that just like it's easier for like managers to manage the team when your team goes like more than like 15 people or something.
Yeah. Yeah, it's a really good question. As we really grow, does some of that start to segregate out a little bit? You know, our data engineering team is a little bit more spread out, so it's a possibility. But yeah, we have a pretty small team actually. So for 100, I'm curious, like for 130 teams, 3 models per team, so that's about 300 models in production. How many people do you think work in our data science department? Any guesses?
3.
Well, this guy knows. This guy knows because we worked with him for a couple of years, and he did some great work for us. Yeah, there's 3 people that manage all those models and do the new stuff, and the only reason that we get away with that is largely in part to Riker too. Like everything has to be code driven. Like your infrastructure has to be terraformed. You cannot be, every time you click a button in the console, you got to be like, what would happen if I had to click that 10,000 more times? So that's what we bring to the table as technology experts, is you have to figure out really innovative ways to scale your own work, right? So that's how you just get a lot done with a really small amount of people. Yep, back there.
I'm curious to kind of understand what are the kind of some of the trends you're noticing amongst the different sports leagues. So I've read a lot about how MLS is kind of a growing league. Just curious on your thoughts of what are the different leagues coming to you and asking for in terms of product, or certain leagues asking for customer segmentation more so than other leagues, and what kind of impact are you finding that's having on those sports leagues?
Yeah, a huge question. And I know I have to be done at 4 here, so we can chat after. But I'll give you one example. Younger generation doesn't want to watch a 5-hour baseball game, right? They just like, it's boring, and yeah, they maybe it's just not their thing, right? So MLB is having to really evolve. Like, how do we still get people to the stadiums? How do we sell different types of tickets? Maybe we're not going to get a bunch of people buying full season tickets to the Jays anymore to go to every single game because they just don't want to watch that length of an event. And so that's where we come in and look at their data and look at their strategy and go, okay, well, what can we do with that? And so just as an example, a lot of MLB, they're experimenting with things like converting whole parts of their stadium into like a bar, and charging people, less money to go. And it's not a great seat, but, would you rather go to the bar down the street, or would you rather go into the Jay Stadium and have a couple beers and watch the game? So they're finding creative ways to kind of, still get people into the stadium. But yeah, that's just baseball. I mean, I love baseball, but, so yeah, great question. But sorry, I got to shut it down. So come find me after if you want to ask another question. But thank you so much. And thanks for